Welcome to Creation Station Monthly. I'm Bob from Creation Station. This is our monthly show, different format than what we do every week, where we're going to talk about one topic with some creative people. We're going to find out what makes their mind tick, how they got into this field, what makes them think about creating in this kind of field. As always, creationstation@broward.org comes right to us if you have any ideas for a topic. This month's topic is robotics. And we have someone from right here in South Florida. Giovanni, how are you doing today?
I'm doing well.
So, Giovanni, you are in, you know what? I'm going to let you do the introduction. You tell me and tell everybody a little bit about yourself. How did you get involved with this right now, what you're doing with robotics?
So presently, I am a self-employed robot programmer. I I work primarily on FANUC industrial style robots.
Okay,
Um,
so tell us what a FANUC is.
so FANUC is a Japanese robot manufacturer. They're one of the largest robot manufacturers in the world. They are one of the most popular industrial robot suppliers, and they provide a complete ecosystem for automation solutions from training to software to the physical robots. I program FANUC robots primarily, and I'm a contract programmer. So oftentimes with industrial robots, they they are assembled in what's called cells. So a
Okay.
cell is the robot and all of the systems around the robot that the robot needs to perform a certain task. Um,
And what kind of, for these robots, I'm kind of jumping ahead because I'm like, this is my field. I want to know about this stuff. Um, when you're talking about certain tasks, how generic or specific are some of these kinds of robots that you're working on right now?
sure, I'll give you a couple general and then specific examples. So here in Florida, I work a lot with pick and place, machine tending, sorting, and excuse me, depalletizing. Generically, um, it can be almost anything, but some specific examples of what I've worked on in the past are sorting applications for small parts, roughly an inch to inch and a half in length.
Okay.
High-speed
So
sorting
you're talking like
applications.
reaching into a bin and taking out some of those small.
Correct.
Okay.
As well as machine tending, which is pulling parts out of a machine and placing them on racks for operators to remove the parts.
Okay. So now I think most people have an idea of how robots. We're not at Rosie from the Jetsons yet with robots around the house. Although, I mean, like at my house, my Bob, you're not home today. The Roomba's going to clean the kitchen for you. I'm like, great, nice, thanks very much. Um, your kind of stuff is industrial things. Where did you get your schooling for that? Is it separate schooling for doing something along those lines versus, like I said, like something a much more specific task like a Roomba, or is a Roomba even that more of a specific task, I guess? Maybe I'm jumping the gun on that.
So my schooling it actually comes from FANUC. They have a training program, and the way I got into that is I was working at a company in Naples, Florida, that had purchased a FANUC robot, and they needed someone that could program it. I had no prior knowledge of programming these industrial robots, but I was very interested in robots. So they were willing to pay for my schooling as long as I would
Hmm.
program the robot. So that's how I got into it. I ended up taking the FANUC training course and learning the basics. I developed a good relationship with one of the FANUC representatives here in Florida, and he was able to help me fill in some of the gaps in my knowledge. From there, I was reading the manuals, I was following up with their tech support, I stayed in close contact, and it was very much a self-taught learning process as far as how to program the specific robot. And in the future, I look to taking more of their classes to
Okay.
further my knowledge.
How long did it take you to go from like start to finish, do you think?
with the
with that portion of the training classes.
it's a 2 week process.
Oh, that's really fast then. So tell us, okay, give us a more background then, because there's a lot of people who can't you just walk out of high school. Oh, 2 weeks in, now I'm programming industrial robots. There's got to be a little bit more to that. Fill us in on that background there.
Yes, you're exactly right. It's it's been a lot of culmination leading up to that point. So I'll start where it started for me, which was was really just in grade school with my father. My father's a mechanical engineer, and I
Okay.
was always doing projects with my father, always doing woodworking projects. We'd go to Home Depot and do the woodworking projects they'd have there for
Yeah.
little kids, and that really got me interested in machines and how they work and building stuff. So fast forward to high school, I went to St. Thomas Aquinas High School in Fort Lauderdale, and my friends and I started a robotics team there because there was a couple of us that were interested in it.
What kind of
Um,
which robotics were you at,
we
Next or Vex?
we participated in First Tech Challenge,
Okay.
um, which is it's similar to the Vex robotics challenges. We started a team to participate in that, and we were mostly self-taught. We kind of stumbled our way through it, but it was a lot of fun, and we really learned a lot along the way. We were very passionate about it. Um, and then in college, I had an opportunity to become a teaching assistant for one of the robot-centric classes at the University of Florida. The class is called Design and Manufacturing Lab. It's a standard class for mechanical engineers.
Okay.
One of the focus for the classes is building robots from scratch, essentially, to perform a certain task, very similar to First Tech Challenge, but with a more structured engineering approach.
Okay.
So I've
And what
really
kind of stuff? Now, when you say building, like for anyone who's out there who doesn't understand, Vex Robotics is one of the is a basic robotics kit you can just purchase right off the shelf, or come to the library and check it out. We've got them here at Creation Station. You can check out a Vex Robotics kit, or come into the library and mess around with them. And so, when you're saying build them, are you saying build it from a kit like that and using those parts, or are you saying build it from scratch?
so in high school that we would build them from the kits. It was very much an old school type of building. We didn't use CAD. We didn't really plan. We were high school students learning our way through it, and it was very much through the kit. And you can build great robots from the kit. In college, design and manufacturing lab, the core focus of the class was the manufacturing process. So we would actually teach students how to design from scratch the components they would need minus
Hmm.
motors. But for example, motor hub, wheel hubs, mounts for the motors, brackets, how to design the grippers. And in the class, we would teach them how to machine or form or weld those objects as they wanted to. So a little bit more advanced.
Nice. So it's a lot more hands-on physical things too. So it's not just coding that you guys were working at. If you're doing welding and you're doing all those other bits, you're doing all the mechanical type stuff on that side.
Yes, that's something a lot of people don't realize about robotics is the diversity of fields you can that you can have in robotics. So there's definitely the mechanical aspect as far as building, designing, or working on components to assist the robot in its job. There's the electrical aspect, which is the wiring of the robot, connecting it to the peripherals, and getting circuit boards made
Hmm.
for your cell. And there's also the programming aspect, which is where I've decided to specialize in, which is the logic side of it, the controls side, and and it's very much a puzzle.
And how about, so when you're working on those, like you said, for that puzzle idea, when you're trying to do the programming, can you come up with your programs without knowing the equipment? How, or I guess, how much is that intermarried? I'm guessing quite a bit, but how much of it can you do as a coding block, for example, where it doesn't matter whether it's going to pick up small pieces or large pieces or a pallet, like you were saying earlier?
Well, typically before we start programming, we like to have a general idea of what we will be doing. So some of the applications I listed off earlier, pick and place, machine tending, depalletizing, those are all very similar. And and when someone says I'm doing a pick and place application, you have a very good idea of what their program will look like. Now, where the specifics come into play is what's the size of the parts? How many parts will there be? What is the
Mhm.
array size that I'm going to
Yeah.
place the parts in? So as far as that, I can gauge the complexity of my program based on what application it will be.
Okay. Nice. And now, as I was teasing earlier, I mean, even I mean something as simple as a Roomba, there with all its little built-in AI and stuff like that. How's that affecting you in the field with that kind of stuff of these newer protocols, I guess would be the way to is that the correct what would be but what is the right term if I'm saying I'm going to add AI to your robot so that it can just automatically pick with the sensors what things to take out?
That's a
What
good
is it? What
question.
would that be called?
That's a good question. And that artificial intelligence is not something that I have explored much in my field. And there's a good reason for it. It's still very experimental. And for for factories to implement something, they want to know that it will work the exact same every
Yeah.
time. There is an application where artificial intelligence is used, and it's in machine vision. And we do use that in robotics. We use it for training. So to give you an example, if I take this pen and I
Hmm.
want to pick this pen from a bin of parts, then I can use artificial intelligence, which usually comes built into the robot software, to identify the pen by taking pictures of it in different orientations,
Hmm.
tilts, and uh, distance from the lens.
Yeah.
That's where artificial intelligence comes in with our programs.
And would you be able to do that? Does the AI then just know this is a pen regardless whether it's black, blue, orange, whatever?
It will know this is a part, and
Okay.
you can obviously train it to the different colors. But one thing to understand about robot programs is they don't know that what a pen is.
Oh yeah, yeah, yeah. You're right.
Yeah.
Yeah, they're just taking it as an individual part. Yeah. But so now when you're doing your programming, you can actually program it nowadays to be able to say, okay, I want the blue pens here, the orange pens here, pick them up and sort them out afterwards. That's all part of the basic programming that you're doing now.
Yes. So for sorting applications, it's very easy to sort by shape, size. Sometimes you can use artificial intelligence to recognize features if there's a hole in the part, or you can look at barcodes. It's very common to look at colors. An interesting fact is actually most machine vision cameras are black and white. Oh,
Hmm.
excuse me, not black and white. I meant to say grayscale. And they don't actually see colors, but they still pick colors. And what's very common in robot machine vision is using filters and colored lighting.
Okay.
So when we talk about machine vision, it is, if you have any sort of vision process, lighting is the biggest thing to make sure you're going to pick what you want to be picking. So say I want to pick a red part,
Hmm.
then I might put a red filter on my camera, and the effect that will have is it will brighten the red in the image and cut down all the other colors. So that's
Okay.
some of the
Cool.
tricks we use to pick colors.
Cool. Nice. That's it. See, some future programmer's going to hear that and say, "Oh, wait, that's how I needed to solve that," or "That's how they solved it back then." Hopefully, they're looking at us. That takes me back to a little thing about that. So, when you are when you started working in here and you started coming up with the idea of, as you said, you really liked robotics, you liked doing the mechanical stuff, and then it's becoming a career, and this is where you really are. Where do you think that line kind of fell for you, and how did you have was it just your dad helping you out, or What was it that made you like kind of click that, wait a minute, I like doing this and I can actually get a job at this?
Um, for me, I've always wanted to have my own business. I've always had a very entrepreneurial drive. And it was really when I was working my first job out of college. I took the job with the primary purpose of designing parts and and running CNC machines. I thought that's what I wanted to do out of school. And the robot programming was just one of those things that I knew I could figure it out and I could do it and I could get it to work. However, once I started doing that and I was also making parts for this company, I realized, hey, I like doing new things.
Yeah.
Um, that was it for me when I realized we already know how to make these parts and we just need to make them more efficient. And then I was doing the robot programming and it was more of we don't know how to do this. We need to figure it out. And if you could do it, you'll be the guy. You'll be the man. So I really liked being on the cutting edge
Hmm.
of I really liked being on the cutting edge and making something that hasn't existed before rather than optimizing an existing process.
And now, so going along those lines, because you said you were in college, you were doing a different thing and coming to here. How much of the people that you're working with right now in robotics, and it maybe are you the only one who's doing it right now in your area? I mean, as you're starting your own company, obviously you're the guy, like you said. But when you were starting to learn this out, were you the only one there learning it, or?
I was the only one at my company. It's a very small company in Naples, Florida, of only 9 employees. When I was
Okay.
working there, I was the only one besides my employer that knew how to program parts and run CNC machines and program
Oh, okay.
robots. So it was it's a very small company, and I really appreciate that because I didn't get paid as much as if I worked at a large company, but
Hmm.
I feel that I learned a lot more. And that would be some advice I'd have to young professionals coming out of college is if you can afford it, take the pay cut and work at a small company because you will grow so much faster than you will at a large corporate company, in my
Yeah.
opinion.
I did a little bit of CNC programming, what, 30 years ago, whatever it was, way too long ago in my world. Um, but yeah, that's kind of the thing. If as long as you're willing to mess around and it's not rocket science, you're not going to blow up something on the launch pad and you're not cutting into someone, so you can make a mistake and you just hope it's not on that really nice piece of material that's being cut, but we make that work.
Exactly right. Exactly.
Um, Tell me, what is your, we'll get back into something else in a minute, but I want to know what's your ideal piece of gear? What you can have anything you want. You can have Rosie, you can have whatever you want as a robot slash programmer type person. What would be your ideal that you think that you want to shoot for the moon with?
So I've thought a lot about this, and my ideal robotics project would be a robot sushi cafe.
Ah, okay.
I
Tell me about
really,
this.
I really like sushi. I enjoy it a lot, and
Hmm.
I like coffee. And my ideal project, and which one day I hope I'll be able to realize, is to have a cafe where robots are basically the chefs, where they're
Hmm.
basically the baristas, and and of course you'll have someone working the register and someone to interact with the customers. But I would like I would like a restaurant like that where people can come and become familiar with robotics
Hmm.
and they can come to see robots as helpers for people. I think that one of the mistakes a lot of restaurants are making as they're trying to automate right now is they put their automation behind closed doors.
Okay.
They've got the robot to flip burgers and the robot to fry the french fries. And it's all behind closed doors. And I think they're missing a big opportunity if they were to put those robots on display. then people interested in robotics could be inspired by the field and it could be an attraction. And I think it would be a great way to get young people excited about robotics, to have somewhere they can go with their family
Hmm.
and get a good quality meal, and also to see something that excites
Yeah.
them.
That's an interesting idea. I know there's a handful of restaurants around down here in South Florida that have the robotic servers. As those are becoming, at some restaurants where, that they just, the kitchen staff loads the server and it rolls it out to the individual tables, et cetera, and stuff like that. But yeah, that's an interesting to go with a full automated kitchen type idea. That'd be really interesting. I've seen some of those much more big, complicated ones, and you're right, they're always big and complicated and behind the scenes kind of thing.
Mhm.
Huh. Never thought about doing sushi though. That's going to take some skill. That's manipulation there for you to be able to learn how to do that. Tell us about that. What kind of equipment is it? Because you do mostly the software side of things now, right?
Correct.
So in the hardware side of things, where do you think that's going, or what's available right now that we may not even know that we have available? Like how dexterous are those things to be able to pick up the parts or be able to interact and do stuff like that?
So the majority of robot applications are highly specialized. So when we talk about cells, that is a complete ecosystem for the robot to work within. And
Hmm.
something to understand is that a robot is just a tool in a cell, in an automation cell. So typically what the robots are doing is not highly dexterous. It's usually just grab, pick up, and then put it somewhere.
Okay.
So most of the complexity in a cell comes from the periphery around the robot, which usually is also programmed with the robot. So I'll give you an example. Say I've got a conveyor belt that carries parts to the robot, and then the robot picks the parts off the conveyor and puts them in their assorted bins. After
Hmm.
those bins, they move on to some other sort of processing. So as far as robot tooling itself, it's actually hasn't changed in quite a while. Just open closed grippers, welding for automotive industry, painting
Hmm.
also very common in the automotive industry.
Yeah, my
Vacuum
uncle
grippers.
worked on those back on in Detroit on the assembly lines. He was one of the first people out there working to fix those. He back in the 70s and 80s, the big huge monster robots that were doing the just doing the painting or just doing that spot welding thing, like you said. Yeah, super specialized, only able to do that one thing. Yeah. So now tell me about that going forward on yours. You said that these are still fairly straightforward. Is it that it's too complicated for the mechanical part of it to, try and duplicate the digits of a finger to be able to manipulate more? Or is it that it's just not needed? And it's just that's a science fiction thing, but we don't really need that.
Well, for industrial applications, it tends to not be necessary. So if for example, I'm picking the same part out of the same machine 1 million times in a row,
Hmm.
then it's typical to just design a gripper that will contour perfectly to that part.
Okay. And just have multiple different robots doing each of the individual pieces instead of one robot that can manipulate each of the different ones.
Correct. So my only caveat to that is in regard to a rising trend of robots called cobots. So to explain cobots, I'll first
Yeah,
explain.
yeah, yeah. I want to hear this one. Yeah, I want to hear what a cobot is now.
Yeah. So when we think of typical industrial robots, they are not rated to work alongside people. They are usually fast moving, they're very heavy, and they can be dangerous if you don't have the proper protection around them. So typical industrial robots will have a protective fence to keep people out of their operating area while
Okay.
they're performing their tasks. A rising trend is with cobots right now, and they are meant to work alongside people in their everyday jobs without external protections. What makes them able to do that is they have built-in force sensors and they have no snag points on them. And if they were to bump into, say, your arm or
Hmm.
your shoulder, they would stop without harming you. And it is a very quickly becoming popular because as restaurants and other workplaces are trying to integrate robots into their facility, they may not have the space to put up a 8 by 8 foot fence, or they may only have a workstation next to a machine that they need to fit a cobot on.
Yeah.
So that's becoming very popular, and
I
the
think I need one of those
cobots.
for my Roomba so she doesn't keep chewing up my phone cords, my charging cables. Yeah. Hmm. So these cobots, so those are things that are being able to be worked on. You're still talking industrial applications though, right? You're not talking like having them out with the public and doing those sorts of things.
It's still industrial, but the advantage to cobots, another advantage is that they're very easy to program. So it's becoming more accessible to the public. If any of your audience has ever programmed Lego Mindstorms,
We have those at the library too. We've been doing a lot. We did a lot of stuff with those pre-pandemic with programming and stuff. As people are starting to come back in, we'll start more of those programs back up. That's a good idea. Yeah.
perfect. Yeah, the cobot programming, companies have put a lot of work into making the cobot programming almost identical to that block format of the Lego Mindstorms
Oh,
programming.
okay.
So it's actually
And like,
becoming
kind
very
of like
approachable
Scratch
for
programming.
people.
Have you used Scratch programming for that kind of stuff? Or is that even too simpler? I know I've done some Scratch programming with some of the kids around the library.
I have used it, but not for robot programming.
Okay. Interesting. Interesting. So tell us about what you actually got started with. So you were saying you were on the job, you had CNC machines. What was the impetus? Was it just that we've only got 6 people here, somebody's got to learn how to do this? Or how did you make that jump into getting into your first chance of really using the robots and programming them?
So at the company I was working at, they had small parts that needed to be sorted. Unfortunately, I can't give you
No, no,
very
no, no. Yep.
specific information, but
Yeah.
we had millions of small parts that needed to be sorted. I would say there was about 40 different types, all mixed together, and more coming in every day. My employer had purchased the robot to sort, with the idea of sorting these parts, went and took the class, and as happens with most business owners, it business picks up, time is
Yeah.
short, and there's not much time to do it. So the job given to me was, hey, we've got this robot. It was a major investment for our company. We have no tooling to go with it. We have no setup. It's up to you to make it sort these parts. And
Awesome. Awesome.
they gave me a small budget and a lot of time, and they were patient with me. And by giving me that room to explore, I was
Hmm.
really able to deliver a high quality and fully functional product to them.
Nice. So along that line about experimenting, and we always talk here on the show about what are our biggest successes and what are our biggest failures. Tell me, what's the big failure? Obviously, you're still here, so the robot didn't kill you. That's a good sign. Tell us about what's something that can really go wrong though in what you're doing and how you're doing it.
Mm-hmm. So obviously, there's a lot of complex systems with robotics, and for me, the biggest challenge was with the vacuum system. I've never worked with vacuum systems before,
Hmm.
and on this particular robot, we had a suction cup on the end to pick up small parts. The the robot would pick up the part. First of all, it would take a picture of the part, determine which part it is, pick it up, and then place it in the correct bin. And the biggest issue, which we struggled with for months and months, was we would run the robot, and all of a sudden, in the middle of the day, it would start throwing parts off of the vacuum suction cup. And what we end up finding is that we need to really clean these parts well, because for the first 100 parts, it works great. For the
Hmm.
first 1,000 parts, it works great. When we get to 10,000 parts, the suction cup starts getting dirty. And so there was quite a bit of research that we did, trying different suction cups, different manufacturers, getting custom cups made, and basically trying to fine tune our vacuum system to our specific application.
Gotcha. That's an interesting little twist there. Yeah. So that counts as both a struggle and a success there for you, huh? That's not bad.
Eventually, yes, we were able to find a good manufacturer, and we were able to do longevity testing that resulted in acceptable results, and
Good.
get on a maintenance schedule to ensure that our parts would be reliably sorted.
Nice, 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 nice. So now, what do you think about how does in a lot of these fields, a lot of these creative fields, sometimes people look at it as it's either not accessible or oh, that's a cool thing to do as a hobby. Where do you think robotics fits into that for the average person? What do you think the average person out there is thinking? Is it that it's still too complicated to understand, or what?
Are you asking specifically about
What
industrial
you think,
robotics?
or any other robotics? What do you think? What do you think as just as a general idea, what the public thinks about what you're doing?
So I will start from the perspective of I will start from the perspective of a high school student, and then I'll
Yeah.
give another perspective after that. But if I were a high school student today looking to get into robotics, I would tell you it's 100% accessible. Look into Vex Robotics, look into First Tech Challenge, look into some of the local competitions, and see what teams are available near you. Go visit them, see if it's something
Mhm.
you like to do. The nice thing about competition, and I love competition because it keeps you motivated. And so if I was a high schooler looking for a new hobby, I would say start looking for some of these competition based ones because it will excite you. Now, if I was a young professional looking to get into robotics, I'd take a bit of a different tack. I would say look at look at who's look at who's making robotics in your area. Look at who's your automation specialists. Look at who's making robot cells. Call them up. See if they'll give you a tour. See if they'll let you visit. A lot of times, these companies are extremely excited to have new people come in. And if it looks like something that you're interested in is possibly a career, then find out where you figure out where you would best fit and apply. That would be my recommendation.
Nice. And I think yeah, you hit on a little point there that just kind of like glossed over a little bit. This is not robotics nowadays is not just one or two big locations around the country where people are learning and doing this stuff. This is every day just in the warehouse around the corner. They've got robots there that are doing stuff and they need people to work on it.
Yes. Another thing to keep in mind is that robotics is more than just what people think about the six-axis arm. It also encompasses automation systems that may not have six-axis arms, but they may just be old school. Um, a a good thing to keep in mind if you're trying to find robotics programs near you is also to check with machine shops. The machine shops are a great resource because they are like a hub for industry in your area. They know material suppliers, they know automation suppliers, they know the machine suppliers. So if you're looking to get into the mechanical field, automation field, the first place I would go is go to a machine shop and see what information they'll give you if you're interested in that at all.
Cool. Interesting. Nice. I like that. Yeah, I like the idea of, building the community and building where you are rather than going away to some other place. Tell me, what kind of thing do you wish you would have had when you were getting started? Like you said, you started in one path and you kind of veered over to the other one. What would have been different for you if you would have started earlier? Or what kind of what piece didn't you get that you wanted that you later found out that, oh, if I would have known that earlier?
Well, I would say when I was in college, I wish I had more of a mindset towards building my own company. I when I was in high school, I read Rich Dad Poor Dad. A lot of students may have read that book. It's a very interesting book about microeconomics and personal money management. But when I was in high school, I read that. It got me a little bit interested in business, and I always knew I wanted to do some sort of engineering, mechanical primarily. I went to college, but I had a mindset that I was going to get a job, work work my butt off, climb the corporate ladder, and pursue my career like that. And then that works for a lot of people. But when I graduated college, I realized that it works, but I did not find it as fulfilling
Yeah.
as entrepreneurship and as business. So I do wish I had spent more time building up my entrepreneurship skills in college, because one of the biggest struggles for me, surprisingly, is not the robot programming and it's not the mechanical or technical side, it's the networking side of it, which a lot of people don't talk about. But building connections with people, following up on phone calls, setting up meetings, that is has been the biggest
Yeah.
struggle for me.
Yeah, and that's Creation Station business here for Broward County Libraries. That's what we do. We teach all the entrepreneurs and co-working and stuff like that. That's one of the reasons why, the library is there for you to come out and do all these different types of events also and learn and pick up these skills. Come in and try out some of these things like we said earlier with Vex Robotics. Tell me about I got one more question here that I really want to try and tease out of you is what's your vision of getting to, you said we're going to make this fully automated robotic sushi thing. What's your vision about how to get there? Because I think everybody needs a goal. Everybody needs this big grand dream of like, yeah, if I ever had the chance, I do. Tell me about how you think it's going to, not only just you in particular, but robotics in general. How are we getting to that, getting closer to that science fiction-y type of world like that, where we've got all these robots running around? How do we get there?
Great question. So we've talked a little bit about how cobots are becoming more accessible to the public, and I think that's going to be the push to for me to get to my robot cafe. I
Yeah.
My business has a great relationship with the local FANUC representative and with FANUC as a company, and my play eventually, hopefully, is going to be to pose this idea to FANUC as a great opportunity for people to see their robots and to experience how their robots can benefit applications that you wouldn't typically think of robots in, such as chefs on display.
Hmm.
And I think as these companies try to push robots closer towards mm, the I shouldn't say closer towards the end consumer, not as much towards big companies, but closer towards smaller people that or smaller companies, excuse me, that just want to add a simple robot.
Yeah.
There's going to be a bigger demand for them to market it towards non-industrial non-industrial
Yeah, and
consumers.
that's where I think my question is, 'cause in the industrial setting, like you said, you can make a robot that does this. Each of the three sections of the line, a different robot handles each one of those pieces, each one of those sections of the line, and it's really done well. But in a small business, you're talking about not only limited space but limited funds, etc. And you need more of a robot that can do more than just the one or two actions. Where are we on that, do you think, for programming and stuff like that for robotics in a business or even a home setting like that?
Well, we're pretty close. I'd say the biggest breakthrough in recent times has been, first of all, the ease of programming, and second of all, the increase in popularity of quick change tooling. So typically,
Tell us what a quick change tooling is.
yep, sure. So typically, when you order a robot, if I were to order a robot today, it would not come with any gripper. It wouldn't come with any air paintbrush, vacuum, or anything.
Okay.
It would they just come with a standard mounting plate on the end of the arm, and several companies have Robot IQ being one of them that we've worked with extensively, have developed with some quick change tooling, which are basically grippers of various sizes, suction cups, and standard tooling that will perform general tasks. I would say you can find a tool that would perform 99% of the tasks you want to do. And
Okay.
you don't need a special machine shop to make it. You don't need a you don't need special programming knowledge. They integrate seamlessly with the current programming language, and it makes it very accessible for people that want to just get a robot and have it do a simple task, because they can order the robot, they can order the tool, it clicks into place as intuitively as you could imagine, and right away you're picking up parts, you're placing them. So I think that's been the biggest jump that's been made in recent years.
Where are we looking at price point on these nowadays?
So for, I would say, average size robots, for collaborative robots, you're looking anywhere from, at the time of filming,
Oh yeah.
anywhere from 17 to $25,000 would be a typical
Okay.
range. And what you have to consider, I know it is a lot for small companies, it is a 24/7 employee.
Yeah.
This is an employee for you that will perform a task from the crack of dawn till the crack of dawn the next day, and they will do this 8 years without needing any maintenance. And when you're asleep, they're still going. So even though it is a larger initial investment, this is typically will pay for itself if you can find a good application for it.
And these are all the way you just said that, it just made me click in my mind. These are all fully electric, um, plugged into your just your general electric system for the electrical system for your business or in your building. This is not something where these robots are mobile, right? For the most part.
Correct. So that's a nice thing about the collaborative robots, cobots, is that they've moved to a 110-volt system and moved away from the 240-volt system that was a big barrier for a lot of smaller companies.
And now those are able to, are the cobots to the point yet where they're moving like the smaller little Roombas and stuff like that? And I know Amazon uses a tremendous amount of those larger, more industrial Roomba type machines to move stuff around inside of their just distribution centers. With those cobots that you're talking about, I mean, they still look like an industrial robot. They just have better sensors and less protections or less need of protective thing.
They're more streamlined. There's no snag points on them. Typically, if you have a robot like that, it won't move. It will move, but it won't move its physical location.
Hmm.
What I see a lot, and what actually a company that I'm working with now, what we are working on, is one of those robots on a cart.
Okay.
So they have designed a robot system with a cobot for an injection molding factory that has many different injection molding machines. They've got a cobot on a cart, and what they will do is they will wheel that cart to the machine that they want to automate on that day, and the cart has a mounting point, or it will
Hmm.
mount to the machine and with a solid mount, and that way they only need to buy one robot for multiple machines.
Yeah, that's a nice idea. Now, how there's your challenge: get that robot to be able to move from machine to machine on its own without having to be wheeled on the cart.
It's doable. It all comes down to how much you're willing to put into the project.
Yeah, yeah, definitely. I know those feelings. Um, Tell us, where do you think this is going? How fast are we getting to our science fiction future here? Just like that idea there of how much does it just cost you to just figure out how to pull that off? Where are we looking? Are we looking 5 years, 10 years? Or what do you, just your best guesstimate? Where do you think we're to be able to pull off something? Money's not an object. We're going to throw all of it that we can at it. How fast could you actually build your sushi kitchen? Are the robots
Uh,
actually existing now?
I think that the robots exist now. The the biggest challenge is going to be, I think, when it comes to sushi, at least, cutting fish, um,
Hmm.
because fish comes in all different shapes, sizes, and as any chef will tell you, there's very specific ways to cut it.
Yep.
So I think that the big advancements are going to have to be made in machine vision.
Okay.
So physically, we have the ability to grab and to cut and to process. Machine vision and artificial intelligence, which we talked about a little bit before, are going to be the big advancements of how do you recognize this blob-like object. I mean, you've seen a fillet of fish, obviously.
Yeah.
How do you recognize this, that every fillet might come in a little bit different? Every fillet might have different fat content and have different contours, and it's a very complex object to look at. So for I'd say within about 5 years, we'd probably be at the point where you could have a machine vision camera look at a fillet of fish on a countertop and say,
Okay.
this is where I need to cut, and track it as it rotates it, and track it as it is cutting it, and have a good understanding of that.
That's a nice idea. And and you kind of implied it earlier. You're not really kicking people out of jobs. You're just getting jobs that aren't being filled or creating something that you couldn't have possibly afford to do in the first place anyway.
It's correct. So a lot of people are concerned, and this is always the concern with automation, is that with automation, people are going to lose their jobs. It's not necessarily true, um, because oftentimes automation will create higher quality jobs. So instead of having an employee, I'll go back to my sorting example,
Hmm.
millions of small parts, tens of thousands coming in every day. And they would, the company I was at would previously have an employee pick one part up by hand. Okay, which part is this? It's that one. Throw it in the bin. Another part up by hand. Throw it in the bin. And they would have to shift out that employee every half hour to 45 minutes, because if you start doing that job long enough, every part starts to look the same. So that's not a very that's not a very enjoyable job to do. So when we were able to implement that automation solution, that employee was able to go from picking up parts and sorting them to doing more skilled work and more enjoyable work of of running a CNC machine,
Hmm.
or of working like picking boxes and putting labels on them, and figuring out what size parts or what size products go in which boxes. More skilled labor than sitting at a desk for 8 hours a day and
Hours,
sorting
hours.
parts.
Yeah. Yeah, and I think that's the key thing is let's automate the repetitive things that don't require real human intelligence that can be just bing, 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 and let the people do the thinking. Let the people actually work and do this kind of stuff.
Exactly. Smart employers will use those resources, because
Yeah.
that's your biggest benefit to having employees, is that they over robots is they can think, decisions that they can make decisions on things that don't often come up.
Yeah, and it's going to be a really good thing, I think, for everyone who's thinking about this as their possible career working in this kind of field. Think about those ideas of your big plan, your big idea. Where do you get? It's not a sushi restaurant. Giovanni's already got that one covered for us. He'll let us all know when that happens. But what are we going to do with all of this? Like I teasingly said, I don't, when I get home, I don't have to vacuum because my little robot vacuum did it for me while I was at work. That's the key, I think, of where we're going with these things and why I really want people to get a feel for what's available in their own futures.
I think you're right. I do believe time is going to be the commodity of the future, and the more we can give back time to people, the more they'll be able to spend that time with their family, pursuing quality moments. I think that really is part of the pursuit of robotics, is that we're chasing time,
Yeah,
essentially.
yeah, it is. Well, our hours is just flowing on by. Thank you so much, Giovanni, for being here with us. Let me throw up our final slide here as our wrap up. Um, again, today, Creation Station Monthly is all about robotics. creationstation@broward.org comes directly to us if you have a popular topic that you'd like to see, or if you have a question or comment for one of our guests, email it to me and we'll get it on to them. Thank you guys very much for being here today, and we'll see you next month.
Thank you so much.